I think also this like these big machines that we have nowadays also have led to kind of a like a brute force approach, right? So we're trying to build bigger and bigger, more complicated model and feed it with more and more data, but we don't really know what is happening under the hood, and that also is part of the problem. Yeah, I mean in a way it's also the way that like how this research is structured, right? So research is a very like highly competitive activity, and these as I said, so having these sort of example data sets, and then you're trying to build systems that perform well of them, right? So it gets very like metrics driven.
Hello, everyone. Welcome to your brand new podcast called In Your Shoes. This podcast is for you to learn more about new people and professions from around the world. I would like to take you on a journey to understand the life and times of a new person every 2 weeks and get a chance to get into their shoes to learn what they do, why they do, and how they do it.
Mikio is a respected technologist and researcher with a deep experience in software development and machine learning. I met Mikio at my work and I found him to be an original thinker who is well connected and has a pulse on the latest and greatest in the field of applied machine learning. It is so amazing to have him on the podcast today. Welcome to the podcast, Mikio.
Hello, thanks for having me.
And am I pronouncing your name correctly, the first name?
Yes, Mikio. Yeah.
Brilliant. So, Mikio, for our podcast listeners, could you kindly share a little bit about yourself, like where you come from and what you do for a living?
Okay, so I'm German. So my mother is Japanese, but I was born and raised in Germany. And currently, I'm working as a staff data scientist at GetYourGuide, a startup that sells like touristic activities around the world.
And what does a staff data scientist do at Get Your Guide?
So the staff level, that's like one level above the senior level. So, but I also just started a couple of months back. So I think it's actually a bit. I think it's still in flux. We're still trying to figure out what it exactly is. But the idea is sort of to be a data scientist, but to have a wider scope than a senior who works in a single team, and look at topics and projects that have a bit broader impact across the company. So for example, one of the topics that I'm looking after is how to improve the general tooling that we have to help the other data scientists get better at machine learning, or to do that more easily.
Okay. And for the broad range of our podcast listeners, could you explain what does a data scientist do?
Okay, so data scientist. It's kind of like so I think it's a developer, right? So you write programs, but at the same time you're also good at analyzing data. And then like you probably heard about AI and all this stuff. So essentially, the data scientists are familiar with all the basic technology that's required to write programs that can learn from data and maybe even do something intelligent. So you're essentially writing programs, but you're also using statistics and all kinds of like complicated mathematics to make sense of the data, and then do stuff. And usually in the context of a company, you work on parts of the product where you have to sort of, which are not as clean cut as you could just have a program write this, right? So one like example is so on any e-commerce website, you have these recommendation boxes. So every time you see a product, you have like a list of stuff that's sort of similar. And so it's quite hard to come up with good recommendations just by writing a program. So what you usually do is you look at the behavior of the customers and then figure out actually what are similar products to the one shown. And this is like a typical application case where you have a data scientist who gathers the data, analyzes it, and then creates something that hopefully works in a way that makes sense.
Brilliant. Thank you, Mikio, for explaining that. And you mentioned something in your reply about creating and deriving intelligence. So for me, it's very interesting to hear how do you see intelligence and how do you define intelligence?
Aha. So I think the interesting thing about intelligence is that it's so we don't really know what it is, right? So I think, or like, so ever since we had computers, people started thinking about how you could make them stuff that sort of we're doing, right? So I think when they started in the 40s, um, it was I mean, computers originally started as a way of automating computing. I mean, numerical computations, which before that, so people were really doing that by hand, and then they had some like computing machines or something, and then suddenly you had a computer which you could program to do like a whole set of complicated computations, right? And that was very impressive. And they thought, okay, if computers can do this, then so how long will it take till computers can do anything that the human mind can also do? But then, of course, now that's, I don't know, how many years is it? 80 years?
Yeah.
And we still haven't figured it out, right? So it's pretty elusive what it exactly means. Um, but the way that the sort of that we're approaching this question right now is often through defining specific tasks where we would say, okay, this is something we need a human to be able to do that. Um, so, for example, to recognize like what object is shown in a picture. So whether it's a picture of a dog or a cat or something, right? And then you can compile like lots of examples and show it and say, okay, if somebody can do this with very high accuracy or a machine can do that, then that's like one form of intelligence. So yeah. So yeah, but I mean, there are many different aspects to it. So there's like understanding what is in pictures. There's language understanding, translation. Then of course the whole area of games, right? So we got quite good at having computers that can play like strategic games and so on. So it's less like we don't really know what intelligence is, but there are many tasks which over the time we've tried to tackle and actually write computer programs that can solve them.
Right. I think it's very nicely put. Uh, so, Mikio, this brings me to this curiosity that what made you choose this line of work, and why do you do what you do in your day-to-day life?
Yes. Um, yeah, actually, I think this goes like way back. So I was like a classical computer nerd. So I started, I don't know when I got my first computer with 10 or 12 or something. And I just started learning BASIC. So it was back in the 80s. So we were all programming like small little programs in BASIC. Um, and I don't know, at the time, I already always had this interest in artificial intelligence. I found it very fascinating. So I was um, yeah, reading books about that, uh, and of course, I loved sci-fi, and so I think the original appeal was always sort of to have like a constructive model of the human mind. And I don't know. So when I started, and then I decided to study computer science, but I always wanted to go into that area, and then yeah, somehow, so I also ended up doing the masters in like this area. So machine learning, as it was called back then. Yeah, and I was doing all of that, right? And then I think that the term data scientist that only came up like in the mid 2000s. Um, yeah. So actually, I stayed. I mean, in my career, I did a master, then I did a PhD till 2005, and then first I was a postdoc, like a researcher in machine learning for I think 11 years before I left there. I left academia and joined Zalando, where we two met. So actually, I was sort of following that whole um, research, trying to figure out how to build intelligent machines for I would say the majority of my professional life so far. But it really started already when I was like a teenager. I was already very interested in all of that.
Thank you. So, when you look back, Mikio, in the time where you were a teenager and being inspired and curious about this field, and now today in 2020, how do you see this whole field has transformed? How do you see that transition?
So, I mean, obviously we have like a lot of progress, I think, which I think also came from having like faster and faster computers and bigger computers and being able to process more and more data. So that's like super impressive. And there are like small things like so how well like a smartphone can understand if you speak to it, right? So I still remember like the first systems that they deployed like on a phone, so where you could call a hotline and then you would talk to a computer. I think the Deutsche Bahn had a system where you could call it and you were talking to a computer and you could get a schedule, and it didn't work at all, right? So there were like comedians calling that number and just saying something and making fun of it. It was really hilarious. And I needed the small things, and then nowadays it works really well, right? So there's a lot of progress in these areas. But then at the same time, I'm also wondering whether we really got any closer to having like really intelligent systems, because it seems like we got really good at building systems that can imitate a specific like skill or task, right? But we haven't put these things together to like to have something, or sometimes also it becomes quite clear that something is really just still imitation. So, for example, we have these. So, in the past few years, there was a lot of progress made on like speech models. So, models that can. I don't know if you heard about that, but so you have models that actually they sort of predict what the next good word in a text could be, but they are so rich that they actually you can sort of seed them with a few sentences, and then they can produce a few paragraphs of stuff that looks more or less coherent. So Facebook is working on that, and Google and all of them. But if you look at these transcripts, right, it's really odd. It's like somebody who's sort of barely listening, who's just trying to come up with something that sort of fits the topic. So it's like on a higher level, it's still very, very inconsistent. And you can see somebody's, or if this were a human, right, you would really question their sanity, because they seem super incoherent. So it's like grammatically correct, but they're jumping around and they're contradicting themselves and all of that. So yeah, so on the one hand, like a lot of progress, but I think there's also like it's still something lacking in the approach.
Thank you, Mikio, for sharing that. As a practitioner of this field, Mikio, what is your take on why is it hard to solve this problem, and why it takes a longer time to be able to accomplish building intelligent machines?
Yeah, that's a good question. I think part of the problem is that we don't really know what the problem actually is, right? So we only always have these small tasks or bigger tasks, and then we can try to build something that sort of works well. But I think also this like these big machines that we have nowadays also have led to kind of a brute force approach, right? So we're trying to build bigger and bigger, more complicated model and feed it with more and more data, but we don't really know what is happening under the hood, and that also is part of the problem. Yeah, I mean in a way it's also the way that like how this research is structured, right? So research is a very like highly competitive activity, and these as I said, so having these sort of example data sets, and then you're trying to build systems that perform well of them, right? So it gets very like metrics driven, and that also I think if it's something is very metrics driven, it's also often the case in the company, right? So you tend to forget what the actual goal is, because you're just trying to push the metric to get better numbers. Yeah, but yeah, I think so so we have started to also try to get these more integrated systems that don't just do a single task, but are more like interactive in the real world. So in a way, like autonomous driving, you could see these as robots who are actually like out in the world, and right, so they have to do like a lot of things to be able to perform well. But actually, if you look at what these systems are doing, you see that a lot of them is still like proper classical engineering and less like data-driven intelligent stuff, right? So if you have a car and you want to go somewhere, like a lot of the route planning or the actual like lane changing stuff, that's all more like classical engineering.
Right. And Mikio, when I asked you about how have you seen this transition, you mentioned about uh, we are not yet there to solve intelligence, and I wanted to understand from the time that you were a teenager and excited about this field, and now when you are actually part of this domain and part of this whole group of practitioners who are trying to solve this problem, what keeps you going? What keeps you excited and hopeful for the future in this field?
I mean, so on the one hand, I think the progress is also exciting, but I think also, so I'm always thinking ahead and asking, okay, with what we have right now, what could the next step be, right? It's so like even if we say what we have today is like a lot of imitation and not really intelligence. I mean, we still have stuff that works pretty well and systems that we didn't have 10 years ago. So my question is always, so what could we do now with that? Right. And then I think also over time, so I also got interested not just in the technology per like itself, but also what you can do with it, like what kind of products you could build around that. And then so that's sort of the other, like I think that's sort of the computer scientist in me, right? Who wants to write programs or build products that are interesting and useful. Yeah, and actually for these you often don't need these cutting edge like intelligent algorithms, but you can still do a lot of useful stuff with using data. So yeah, so I think I think we already, like if you look at the toolbox that we already built up in the last decades, right? There's a lot of stuff you could use. Yeah, and I think we still have there's like still lots of opportunities to do that, and that's what I find interesting.
Okay, thank you, Mikio. So Mikio, you mentioned that you are a staff data scientist at GetYourGuide. What is your typical day, if you have a typical day, usually look like?
Yes. So I think there are like different modes. So one thing I decided or wanted to do joining GetYourGuide was to get more hands-on again. So sometimes I'm just working on some project, right? And then like it's every day, it's a bit like a classical engineering or computer like developer job. Or the day, I mean, okay, if you don't know what that is, right? But usually, so in the morning you have a check-in with the team, so everybody just gives an update where they are, and then you start working on the code, just which can take days or longer, or you're debugging code and stuff like that. So that's sort of the project mode. Then there's another thing when there's like a bigger topic. So I've started to develop some kind of like approach where, so first I try to talk to everybody to get a picture from everybody about a topic. So for example, at GetYourGuide, right, the question was, so we already have a lot of systems in place, infrastructure for the data scientists, like what are the pain points, what could we change? And what I did is I started like setting up like 1 hour interviews and just ask people and let them talk about like what they're using, what they're doing, what their pain points are, what they think could be improved, and so on. So that's sort of the other mode, right? So lots of talking, and then I take that, I try to organize the information that I got, and then write up something, and then share that again, get feedback, and so on. So I think that are maybe the main. Okay, and then the third is so sometimes I'm just asked to join some meetings as an expert to give my opinion on some topics. Yeah, so it's I think it's so in the best, if it goes well, right, it's a good mix of sort of being focused, working on some code, and then the other is like more conceptual work.
Okay, you mentioned about that this role also includes communication and working with other roles in your workplace. So could you give us a view of how do you work with other people apart from just writing code?
I don't know. I think it's always important to first to get some connection, right? So just meeting up, just talking a little bit about the background, where people come from, what they've done in the past, and then what their current role is, and so on. And then again, I think the way I try to work is sort of understand what everybody's thinking about some problem or what their needs are, and then trying to figure out whether there's a solution. If we're talking about a problem, that sort of is a good compromise between like what everybody needs. So yeah, so it's a part like that is a bit networking, and then I think it's also like listening a lot, talking to people, giving feedback. I don't know, don't know whether that's clear enough, but that's the I would say like the normal part of what you often do, like in a technical role, working with other roles, right? And yes, no, I think because at Zalando also, so I've worked in many different roles, right? So in research, I was a postdoc and I supervised PhD students, and then Zalando the first 2 years I was a engineering manager for developers and data scientists, and then later on I had this principal role. So over the time I worked with many different roles like product managers and department heads and so on. So I think it's also important to sort of understand a little bit how each of these roles work and typically what's important for these roles.
Right. So in a broad sense, Mikio, could you help us understand what kind of skills does a person in your role need to be successful?
Yeah, I think on the one hand, there is the actual technical knowledge, right? So you need to, I think as a data scientist, you can sort of choose whether you want to focus on one specific area of algorithms or have like more broad, or if you want to go into like systems and infrastructure and so on. But I think that needs to be there. So you need to be able to understand how things work, how technologies play together, and so on. And for that, I think also you should have like quite sound understanding of the mathematical basics, right? Because so it's still quite new technology, and sometimes it fails in very like unpredictable or surprising ways, which are also different from I think how classical computers fail. So classical programs, right? So if you have a bug, the program just crashes, or you can look at some error messages or something. But when you're doing data analysis, it could be that the program itself works, but there's something wrong with the computation, right? So there are no error messages. It's just that the output is not what you expected, and then you have to sort of debug, but in a different way. So you have to look at intermediary results and try to figure out what's happening. And for that, you also need to understand how the things work. So that's the one part, right? And then I think it's also quite important because so you have to work with like product managers, with other engineers. So you also have to have like this also with customers, right? So you have to also be able to interface with many different roles well. So you have to have good communication skills, and also to explain like outcomes of your work to people who do not actually have the expertise in that area. Yeah, I think that's the other part. So sometimes let's say if you're analyzing data, and sometimes you just need this for yourself to know how to improve the algorithm, but sometimes you're also actually doing analysis for some product manager to make a decision, like in which way to improve the product and so on. And these are all like different, and you have to be able to explain your outcomes in a way that the audience can understand.
Okay. So one is the whole part of technical skills, and the other is being able to communicate and work with these different roles in an organization.
Yeah.
Okay. I have one last sub question for this. How do you see the understanding of this relatively new field amongst the roles that you work with in past or in your current work environment?
I think the understanding is yeah, can be on a whole range. I mean, as usual, right? So in the best case, you have like say, if you're like for example, I think that it's important that the product manager also has some understanding of how data science, how these methods work, and like what the potential is, because we can shape the way in which a product is designed very much. But I think what sometimes people are not aware of, that like data science is different if compared to if you do like a pure engineering project, because right, so I think with an engineering project it's more I mean software engineering, it's more like there's like the best practices how you do stuff and like ways in which you should organize your code, right? It's more like if you know how to do it, then you have a higher chance of doing the right thing. So if you have somebody who's experienced, they will design a system in a way which is good and so on, to know all the technologies. And I think with data science, so as soon as you have data, there's a higher degree of just uncertainty, right? So you don't know, so you have to figure out stuff, you have to look at the data, you have to figure out whether the data has the information that you actually need, whether the quality is okay, and so on. And that means that also projects where you have a high degree of data science, they also have a bit of different setup. So you have to invest more, or you have to be more comfortable working with these uncertainties, right? So you cannot make like a 3-month plan and then say, okay, after 1 month we have this, but it might take longer or shorter. And managing this kind of stuff is difficult, I think. And I think it's important that the other roles also understand that, because otherwise it doesn't really work. Yeah, and I say so. There are many people who are sort of aware of it, but maybe not like fully. Right? So it's always a bit of negotiation and explaining that's necessary, so that people really understand what to expect.
Thank you, Mikio, for sharing that. I want to take a segue right now to a completely different part of our conversation. So every profession and every job has their own perceptions from people outside, or we sometimes also call it stereotypes. And these perceptions are sometimes true and sometimes outright completely wrong. What are the stereotypes or external perceptions about your profession that you know about?
Okay. I think not just data science, but developers as a whole, or software engineers, they often have this stereotype, right, of being like spending a lot of time in front of computers and not being able to socialize well, and all of that goes with that. And I've been like in conversations where, or like it's for me, it's like whenever somebody asks me like what I do for a living, who's not in the field, right? I'm always very I first have to think a lot, like how to explain it, because I don't want to say I work on AI, right? Which would be an overstatement. But then on the other hand, also it's very complicated, right? So what I'm actually doing. And I remember I've been once at a party and somebody asked me, and I just took like these few seconds to think about what it is. And then they immediately said like, oh, okay, you're a computer scientist or you're a software engineer because you're. So I think what they said is don't try to be like a typical software engineer and just talk or something, right? But actually was something different happening. And I think actually there's definitely some truth to that, because like the work sometimes is, or like part of the work is really like you in front of a computer. But on the other hand, so software engineering is also very much a team activity, right? I think so. Whenever you go somewhere, you're in a team, you have to work with other people, and you also have to communicate a lot. And I think that's why it's not really true.
Okay. Thank you for being open about sharing this. So Mikio, with the wealth of experience and the trajectory that you had with your career, if someone listening to this podcast want to come into the same profession as yours, what do you advise them? Like, what should they learn, and what experiences particularly they should have so that they are ready for this profession?
Yeah, I think so there are actually like two ways in which you can sort of end up in this profession, and one is you're already like a software engineer and you want to go into data science, or the other is that you, for some reason, you already have a lot of experience with data analysis, so I don't know, you studied physics or something, or statistics, and then the other way around. But I think so as I said, so you have to learn like the programming, the being able to do the data analysis, right? I think that's the minimum, and also have a solid understanding of the methods themselves. And so, I mean, classically you would go to university and study it, but I think nowadays there are many like online resources where you can also learn that. And then the one thing that sort of even at university you don't learn is in practice, if you have a project that runs with data science, how do you structure such a project? Because as I said, I think it's different, right? So you have to do that at least once. So I think these three things, like, right, so knowing how to program, then having the basics, and then applying that in a sort of, could also be just like a pet project, but actually going the whole way from collecting data, preparing the data, training models, and so on. I think that's like the minimum experience you should have. And then I think everything which you have beyond that is a plus. So if you could be more solid in programming, or deeper in the statistics and so on,
Okay. So, Mikio, thank you for sharing the information. I hope this is useful for someone who's listening to the podcast and wants to get into this profession of yours. I want to end our conversation with asking you about your recommendations, especially perhaps books, blogs, or podcasts that you think others will enjoy like you do, and maybe relevant for the work that you are doing.
Okay, so yeah, I'm more of a book person, I would say. So I don't. So I think I found most of the blogs blog posts I read either through Twitter or some. So, but there's nothing there which I really like follow a lot. Yeah, I mean, so like when it comes to the basics, I think there are many. There are many books out there that are, I think, good introductions to machine learning. I'm still. I don't. There's not really like one book which I say you should really read because everything's in there. Because there's like traditionally there are the books which are more like university textbooks, but these usually require a lot of mathematics and like knowledge you should have before that. Or there are also more recently many books which assume you're coming more from the programming side, right? So they have Python, and then so O'Reilly has lots of them, and other publishers as well. But so my time reading the stuff that's so old, so I've read like a lot of these. Or if you would read the same books that I had, then it's like 10 of them. So it's hard for me to suggest like one main book. So what I'm reading right now, but on the other hand, so what I'm reading right now, or what I read in the past few years, what I found very interesting are also the like more bigger questions, like how do you organize a company, or how do you sort of build products, that kind of thing. And so one book I found very interesting, it was called The Connected Company, which I think tries to answer this like, how do you structure a company in a way that you can still have teams which are very small and can innovate, but still have a foundation on which you can build upon. So I've read that book a few years back, but I'm still coming back to that. So every time I think about, okay, how do we create like a machine learning platform or something, right? I always find ideas from that book coming back to me. Then another thing which is, I think, super interesting is so it's like a book, but which is on Medium by Simon Wardley, who created a thing called the Wardley maps. which is like a way to think about if you have a company, like what are the different parts of the company, or like the technology stack. So what is like you have a website and then you have the infrastructure and so on. But to visualize that in a way that you can also see like like where are these components like in their life cycle and like what is going to happen, right? So he has this idea of it's not just like a graph, but it's really a map, and then there are like things you can predict because it's always happening. So for example, he says technology always goes from like being new and then being refined, and then at some point it becomes commoditized, right? And that's like and then he says like usually in a company you have some stuff which is really new, and then there is stuff which is like close to commoditization, and that kind of thinking can then help you to decide where to like how to deal with these different things. Like super interesting. Just Google for it, Wardley Maps, and then it's like a 500-page book, which is a series of posts on Medium. And then so finally, I've also been reading. So this is a book I wanted to recommend in some form for a long time, which is more like a philosophy book. So I'm also very interested, I think, in the like what are we humans actually doing on the planet and what's the purpose of all that. So there's a book called the Happiness Hypothesis, and that sort of collects all kinds of like scientific sociology and religion stuff to sort of try to understand how the human mind works and how we find purpose and so on, right? So so for example, it makes some connection. Right, so it sort of discusses like how humans are social beings, right, and this whole idea of reciprocity. So when don't know whether I pronounced it correctly, right, but so how that creates like a web of interlinks between all the humans, and like it's just part of what we have. And I thought that had very interesting perspectives on so many different aspects of human life. So these would be my 3 recommendations.
Thank you. Those are fantastic recommendations, and I will have them also in the show notes so that others who are listening to the podcast can get hold of them. So thank you, Mikio. I think this conversation was very stimulating for me, and I hope this is same for our listeners. And Mikio, what would be the right channel if listeners would like to reach out to you if they have further questions or they seek advice?
Yeah, so you can either on Twitter or you can find me on LinkedIn. So my Twitter handle is just my name, Mikio Braun, and just get in contact with me there.
Thank you. Thank you again, Mikio. It was a pleasure to have you on this podcast today, and I hope we get to talk to you again into something more detailed and more something niche the next time.
Yes. Yeah, thanks for having me. Thanks for listening.
Thank you for joining this podcast. I hope this was useful and you learned a lot. For more such great podcasts, please do not forget to subscribe to the podcast channel In Your Shoes on SoundCloud, Spotify, and Apple Music. New podcasts are uploaded every 2 weeks. Goodbye.